All right, we're going to keep looking at examples of using if-then moves to solve equations, but our focus is going to be on setting up the equations. And what I want you to look for is like some similarities, some like common words that we use to give us hints to help us set up these equations. Okay, this middle one here is going to be a little bit different, so make sure you take good notes on that. But the other two, it's again writing stuff down, figuring stuff out. Okay, so look at example 1 here. A plant is growing at a rate of 1.25 inches per month. It is currently 13 inches tall. At that rate, how many months will the plant grow to a height of 38 inches? Okay, the key word I want you to focus on here is the word per. Okay, per means for every. Okay, so just think about this for a second. If we did 1 month, it would grow 1.25 inches. If I did 2 months, we'd go 2 times 1.25, which would be 250, right? Yep. 2.5 inches, right? If we did 3 months, we'd go 3 times 1.25 or 1.25, and we get like 3.75. And we are adding 1.25 each time, but that idea of multiplying, right, is important because what if this next one, oops, I said, okay, 10 months. All right, how much will have grown in 10 months? We could go 10 times 1.25, which I know I should know, but that's all right. And we could say it's going to grow 12.5 inches, 12.5. Okay, so this word per here, when you see that, per, for each, for every, it's going to mean multiply. And I'm going to use m for month. So we're going to have 1.25 times m. That's how much its rate that it's growing each month, but where is it starting? Well, if it's currently 13, we're going to add 13 on because we're starting at 13 and then we're adding 1.25 inches every single time. But that starting point is 13. And we want to know when it reaches 38 inches. So I'm going to set it equal to 38. Now, again, a lot of us sometimes will start solving it in our head to start. Don't write the equation. Pause. Now we can use our scales to solve equations, okay? We work order of operations backwards. And the last thing we deal with adding and subtracting, that's the first thing we're going to get rid of. So I am solving for my m term, so I'm going to get rid of this plus 13. I'm going to combine it with its opposite, or am I thinking adding, subtracting, positive, negative? I'm going to subtract 13. Whatever I do to one side, I have to do to the other. That gives me 1.25 times m. This cancels to give me 0, equals 25. Okay. Now, how do we undo this multiplication? Because I want to get 1m by itself. We divide. And we divide by whatever this coefficient is. Whatever we do to one side, we do to the other. 1.25 divided by 1.25 is 1m. And then you can just grab your calculator and go 25 divided by 1.25, and you actually get 20. Okay, so how many months? 20 months. Okay. So again, look for those hints. For each, for every, per. That's where we're going to be multiplying. That's our rate. All right, so this next one is a little bit different. You're going to see I have a box here, so pay close attention. Take good notes on this one. So we have Brooke and Samantha here. Brooke is 3 years younger than Samantha. And then it tells us in 5 years what the sum, solution to addition problem, of their ages will be. And it wants us to find Brooke's age. Okay, so Brooke is 3 years younger than Samantha. So I'm going to start by writing Samantha in this box. And then Brooke in the other box. It doesn't matter which one you put in which. But you'll notice I'm leaving this first one blank because I'm going to talk about their ages right now, and then I'm going to talk about their ages in 5 years. Okay. And sometimes a table like this, I write things off to the side. Sometimes a table like this can help us. We don't know how old Samantha is, so I'm going to call her X, her age X. But I know Brooke is 3 years younger than Samantha. So if Samantha's 7, Brooke is 4. If Samantha's 13, Brooke is 10. Brooke is whatever Samantha is minus 3. Okay? But now, what about happens in 5 years? Well, whatever Samantha is, however old Samantha is, you're going to add 5 years to her age. However old Brooke is, in this case, it's x minus 3. However old she is, you're going to add 5 years to her age. Okay, and that's kind of why it helps us to set things up in a table, because we know in 5 years, when we add their ages together, it's going to be 29. When I add this to this, it's going to be 29. So x plus 5, Brooke's age in 5 years, plus x minus 3 plus 5. This was Samantha's age in 5 years. This is Brooke's age in 5 years. That has to equal 29. Okay, now we have to simplify and solve. I'm going to go keep, change, and make that plus a negative 3. And then I'll notice that everything here is addition. And so I'm just rewriting it with plus signs and putting ones in front of the x's so I don't forget that there are 1x's there. And now I can look for my like terms. If I have 1x and 1x, that's 2x's. If I have 5 plus a negative 3 plus 5, well, 5 plus a negative 3 is 2. 2 plus 5 is 7. So 2x plus 7 equals 29. And now notice we're back to the same type of equation we've been solving. I am solving for 2x, so I'm going to get rid of whatever's being added on to or subtracted from first. Plus 7, I do the inverse, the opposite, I subtract 7. I undo adding 7 by subtracting 7. I bring down my 2x, double check to make sure that's 0, bring down my equal sign, 29 plus a negative 7, or 29 minus 7 is 22. And at this point, you can say 2 times what number equals 22, or remember, we undo multiplication by dividing. Undoing multiplying by 2 is dividing by 2. 2 divided by 2 is 1x. 22 divided by 2 is 11. Okay? So we get x equals 11. What does that mean? Well, x right here is Samantha's age. So Samantha is 11 years old. How old is Brooke? Well, Brooke is whatever Samantha is minus 3. So she's 8 years old. So if we're making sure we're answering the question being asked, Brooke is 8 years old. Okay, again, I understand that's a little bit tricky. This table helps us set it up, and then you're just adding whatever you put in those boxes. One more example. Okay. The Kozo family has 5 kids. While on vacation, they went to a play. They bought 5 tickets at the child's price of $10.25 and 2 tickets at the adult price. They spent a total of $89.15. They want to know the price of the adult ticket. So we have the child's price, and we have the adult's price. It tells us that the child's price is $10.25. The adult's price, well, that's what we're looking for here. So I'm just going to call that A for adult. Now, how many did they buy of each? Well, they bought 5 tickets at the child's price. So I'm going to take this $10.25 here, and I'm going to multiply it by 5. I know they're buying 5 tickets at $10.25. Grabbing my calculator, typing that in, that comes up to $51.25. How many tickets are they buying at the adult price? 2. So same thing here. I'm going to go 2 times A. I don't know how much that is. This is what I need to figure it out. So now when I've done both of those things, I can work on solving my equation. Because I'm going to pay for the child $51.25 for my kids' tickets, right? The 5 kids' tickets. And then I'm going to pay 2 times whatever the adult price is. And that's going to equal my total here of $89.15. Let's solve. I'm solving for A. Let's get rid of whatever's being added on or subtracted from it. So I'm going to subtract this $51.25. I can totally do that as long as I do it to the other side of the equal sign. Do you guys see how there is going to be a lot of repeating in this? A lot of what we set up is going to be similar. A lot of how we solve is definitely going to be similar. That gives me 0. I have 2 times A equals, just going to grab a calculator and subtract that, and it works out to be $37.90. We're going to undo our multiplying here by dividing. Whatever I do to one side, I do to the other. 2 divided by 2 is 1A. $37.90 divided by 2 is $18.95. Again, just type it into a calculator. So it asks how much was the price of each adult ticket. That is what I figured out, because that's what A stands for, the price of adult ticket. So ladies and gentlemen, again, focus on setting up the equations. You're going to start seeing similarities and some keywords, and then use our steps for solving, following order of operations backwards.